Hello. So today what I'm going to try to do is explain a little bit about series and parallel circuits, and I'm going to be using some resistors here to sort of help me explain what we're actually working with in some very simple examples. I've actually built two boards here that are almost the same. This entire breadboard here is built with all the exact same values of resistors in both the series circuit and the parallel circuit. This particular breadboard is built with three different values of resistors in the series and the parallel, although they are the same resistors on both circuits, so we'll be able to compare them side by side and see what happens. Let me get this one out of the way. And before we actually do anything, let me explain a little bit about what I've got wired up here. I'm using the PRT motherboard with a TNC 3.1 in it. And I'm actually got this tethered directly to my computer. Okay, so we're going to be powering all this off the USB. Mine works out to be about 4.8, 4.9 volts that way. This wire right here, this red wire, okay, it comes off the positive bus, okay, and it goes into this hole here, which is interconnected with all the holes along the red band. Okay, so all the outer holes are connected together. This wire here, the ground, of course, goes to the ground of the motherboard, and it's plugged into this very first hole along the blue band, and all of the holes along the blue band are interconnected below. So something that's plugged in here is just as well plugged in here or here or here. They're all connected. The last thing that I've done here is to keep this board super easy to use. I actually have run a jumper. For example, this red wire goes all the way across and connects from a hole here next to the red band to a hole here next to the red band, which means that I can get power, for example, here or here. I can pull it anywhere near the red band because they're all connected. Okay, I did that also with the ground. Okay, the ground is connected between both sides, so therefore you can see, for example, these LEDs, they're all hooked into the blue band, the ground, on both sides. Okay, so they're all hooked up to this common ground because this jumper allows for continuity across both sides. So let me zoom out a little bit and let's take a closer look at the board, and we'll kind of explain a little bit what we got going on. Circuits in series. Okay, so here you can actually even see the colors. These are 330 ohm resistors. I have them hooked one after another in series, a long stretch. Remember that on a breadboard that the holes in this orientation, in these columns, all five of these are connected below. Okay, so something plugged in here is also connected to something that's plugged in there. All right, so here I have the power coming from this power bus going into this column of holes here. So this resistor is connected to power, and it jumpers across. It shares two holes on this column with this resistor, which then shares two holes on this column with this resistor, meaning that this resistor is connected to this resistor, which is connected to this resistor, which is connected to the LED, okay, because the LED wire here is in the same column as this resistor, so these are all connected. And what you can't quite see is this wire here is going into the ground bus. So I have a complete circuit. Okay, electrons coming up to the positive side through all three resistors and back down. So they're all 330, and it's actually kind of, series circuits are super easy to figure out. And there's lots of, actually you don't even need a calculator for this, but I'm going to demonstrate it. This is how you calculate the total resistance of resistors in series. It's nothing more than R1 plus R2 plus R3. So R1 plus R2 plus R3. These are each 330, so you would expect this to be 990 ohms. Okay. In this case, it's almost silly to run the calculator, calculate 330s, and it's 990 ohms. And what I wanted to do here is show you a comparison. Okay, so this is 990 ohms via 3 resistors, and you can see the LED is lit up. In this particular case, I have one 1000 ohm resistor, okay, and it's lighting up the LED to about the same amount. And if we, actually I'm going to disconnect power ever so briefly. And let's take a look at these values. Like I said, these are 330 ohm resistors. They should be. Oh, come on. Don't let me down. There we go. So we're reading 300, and I'll move this out of the way, so sorry. There we go. Now you can see it. Okay, 327. It's within the tolerance indicated by the band. And if I go from one to the other, we would expect this to be about 990. So let's see what we got. 980. All right. And what's interesting is we can actually see each step independently by simply moving the LED down. So I've got it on. So currently it's going through 3 resistors. I'm going to move it to the first one. So now it's coming off the very first joint. And you can't quite see it, but let me take and dim these lights. So they're all saturated. Clearly you can see that this one is much, much brighter than, for example, this one. Okay, this one's running off of only the 330 ohms. This one's running off the 1000 ohms. Okay, over here. If I move this to the next coupling, so now we're at 2 resistors, that should be 660 ohms, and you can see that it's actually dimmed a little bit. Okay, in fact, they're getting closer. And now as I move it all the way over here, now we're at the full 990 ohms, and no matter where I am on the scale here, they're pretty much the same. All right, so that's circuits in series. Let me move this up, get it kind of back where it was, and cancel that. All right, now let's talk about series. Maybe actually I'll spin this around so we can get a better look at it. Okay. So here I have 3 resistors that are, let me try to focus that just a bit, there we go, 3 resistors in parallel. Notice that all 3 resistors enter and exit on the same columns. Okay, so these guys are all sharing a similar column. Now you look at that and you go, well, wait a second, there's 3 330 ohm resistors. I'll bet the total resistance between this bus and this bus is probably 330, because I got 3 resistors at 330. It seems as though the average of that should be 330, so that should be it. Well, it's not. In fact, this is a 330 ohm resistor here, and if I do the same game and I dim the light, okay, you can see the one with 3 330 ohm resistors, this one, is much brighter than the one with 1. Okay, well, what's going on? Well, it's because, let me jump back to this, calculating resistance in parallel, you have to do 1 over. Okay, so this would be 1 over 330 plus 1 over 330 plus 1 over 330. And again, we have these handy-dandy calculators, so I'm just going to copy this. Those are 3 330s, and let's put it up here in this resistors in parallel and calculate, and we see that in fact the resistance across all 3 is only 110. So I'm going to pull the power, and if that's right, we should get something close to 110 across all 3 of those. And there we go. Right? Oh, dang it, once again. I've left this in the wrong spot. Okay? So that kind of gives you a quick, sort of fast look at series and parallel. Let's look at the ones where the resistors are all different. So I'm going to take this here, and let's plug it in. I'll move this back to the end. I must have been playing with it. Plug that in the ground. Positive. Same sort of thing on this board. All the either side are interconnected because I've run these jumpers. And what I have here is a 330 ohm, a 150 ohm, and a 1000 ohm. Okay. And over here I have a 150 ohm resistor. And what we're going to do is we're going to take a look. You can see that if I take it from here to here, the light is pretty bright. I'm not going to bother to dim it, but you can see it's actually brighter. And here to here, okay, it gets a little dimmer. And then finally when we get down to here, it is pretty dim. So what's the total resistance on that? Well, we'll pump it into the calculator real quick. These are resistors in series. So I said that was a 330, a 150, and a 1000. We should get 1480. Okay. And let's confirm it. Okay, well, once again, I've got to remember to move this window. Now you guys can't see it. And there you go. Okay, 1460. Okay, and I lied when I said that was 150 because this is actually a 1500 ohm resistor. So if I plug this in, okay, this comes out to be 1480 ohms. This is 1500 ohms, and you can see that our lights are actually pretty close to the same. Jumping over here, we have 3 different values. Okay, I'm going to run over here to this calculator again. I've got the same 3. I've got a 150, a 330, and a 1000. So I'm going to take and copy this, and I'm going to put it here. And you can see that we should be right around 93 ohms. Okay, so I'm going to remember to close this. And let's take and measure it. All right, nicely done. And what I have here is a 100 ohm resistor so that we can kind of compare the intensities, and you can see they will match. I'll do one last thing. We'll take and fade this down. And you can see that they're very well matched. All right, I'll just move this down here one more time now that I have the light dimmed. Like I said, we should see as I move this one get brighter, because now we're going to go to the resistance of only 2. It did get brighter. And last, we're going to go here, and this should be the brightest. All right, so hopefully that was useful in explaining a little bit about series and parallel. And I will see you again soon.